Redox reactions. Introduction. Oxidation and reduction reactions form an important class of chemical reactions which occur around us. For example, rusting of iron, chopped apple becoming brown after some time are oxidation reactions. Similarly, conversion of vegetable oil into ghee, alkenes into alkanes are reduction reactions. Production of heat energy by burning fuel, electroplating are the common examples of redox reactions. Oxidation and reduction classical concept. Oxidation. According to the old concept, oxidation is a process which involves addition of oxygen. C plus O2 gives CO2. 2Mg plus O2 gives 2MgO. Addition of electronegative element. 2Na plus Cl2 gives 2NaCl. Removal of hydrogen. Mg plus 2HCl gives MgCl2 plus H2. Removal of electropositive element or metal. 2Ki plus H2O2 gives 2KOH plus I2. Reduction. According to the old concept, reduction is the process which involves the removal of oxygen. CuO plus H2 gives Cu plus H2O. Addition of electropositive element or metal. Cu plus Cl2 gives CuCl2. Addition of hydrogen, H2 plus S gives H2S, and removal of electronegative element, AlCl3 plus 3Na gives 3NaCl plus Al. Modern, that is the electronic concept of oxidation and reduction. Oxidation. Oxidation is a process which involves loss of one or more electrons by an atom, ion, or group of atoms. Thus, oxidation is de-electronation. As a result of loss of electron, there is increase in the positive charge or decrease in the negative charge of atom undergoing oxidation. Na gives Na plus E minus. Sn plus gives Sn4 plus 2E minus. Zn gives Zn2 plus 2E minus. 2Cl minus gives Cl2 plus 2E minus. H2 gives 2H plus 2E minus. E minus is electrons. Reduction. Reduction is a process which involves gain of one or more electrons by an atom. Thus, reduction is electronation. As a result of gain of electron, there is increase in the negative charge or decrease in the positive charge of an atom undergoing reduction. S plus 2 electrons gives S minus minus. Fe3 plus electron gives Fe2 plus. MnO4 negative plus electron gives MnO4 minus minus. Cl2 plus 2 electrons gives 2Cl minus. Hg2 plus electron gives Hg plus. Redox reactions. An overall reaction which involves both oxidation and reduction simultaneously is called oxidation reduction or redox reaction. Thus, redox reaction is composed of two half reactions. Oxidation half reaction in which electrons are lost and reduction half reaction in which electrons are gained. For example, Fe gives Fe++ plus 2 electrons, which is oxidation. CuSO4 plus 2 electrons gives Cu plus SO4 2 minus, which is reduction. Fe plus CuSO4 gives FeSO4 plus Cu, which is a redox reaction. AlCl3 plus 3Na gives Al plus 3NaCl, which is a redox reaction. 3Na gives 3Na plus 3 electrons, which is oxidation. Al3 plus 3 electrons gives Al, which is a reduction reaction. Oxidizing and reducing agents. Oxidizing agent, oxidant. An oxidizing agent is a substance which brings about oxidation of another substance. It is defined as a substance which accepts one or more electrons and forces the other substance to lose electrons. It itself undergoes reduction. Reducing agent or reductant. It is defined as a substance which loses electrons and forces another substance to gain electrons. Reducing agent itself undergoes oxidation. For example, Zn plus Fe2 plus gives Zn2 plus Fe. 2Na plus Cl2 gives 2NaCl. 2Na gives 2Na plus 2 electrons. Therefore, Na is the reducing agent. Cl2 plus 2 electrons gives 2Cl minus. Therefore, Cl2 is oxidizing agent. Zn plus CuSO4 gives ZnSO4 plus Cu. Zn gives Zn2 plus 2 electrons. Cu2 plus 2 electrons gives Cu. Therefore, Zn is the reducing agent. Cu2 plus is the oxidizing agent. Oxidation number and rules for assigning oxidation number. Oxidation number. It is the numerical value with the sign of electrical charge that appears on an atom of an element in its molecule. For example, in NaCl, oxidation number of Na is +1 and oxidation number of Cl is -1. Oxidation number can be negative, 0 or positive whole number or a fractional number. Valency. Valency is the combining capacity of one atom of element with number of atoms of hydrogen or chlorine, that is, number of bonds formed by an atom. Oxidation state. It is the number of electrons lost or gained by an atom of an element in its compound to form a bond. Oxidation number denotes the oxidation state of the element. Rules to assign oxidation number of element. Oxidation number of an element in the free or elemental state is always 0. For example, oxidation number of hydrogen atom in hydrogen molecule is 0. Similarly, oxidation of O in O2 is 0. Oxidation number of P in P4 is 0. Oxidation number of hydrogen is always +1, except in hydrides of metals such as NaH, MgH2, CaH2, etc. Oxidation number of hydrogen is -1. The oxidation number of oxygen atom in most of the compounds is -2, but in peroxide it is -1, and in OF2, that is oxygen difluoride, it is +2. Oxidation number of O in H2O is -2. Oxidation number of O in H2O2 is -1. Oxidation number of alkali metals in their compounds is always +1. Oxidation number of Na, K in NaOH, K2CO3 is +1. Oxidation number of alkaline earth metals in their compounds is always +2. Oxidation number of Be in BeCl2 is +2. Oxidation number of Mg in MgO is +2. Al has +3 oxidation number in all its compounds. Oxidation number of a halogen is always -1, that is F, Cl, Br and I. The algebraic sum of the oxidation number of all atoms of a molecule is always equal to 0. For example, in NaCl, oxidation number of Na plus oxidation number of Cl is equal to 0. That is +1 plus -1 is equal to 0. The algebraic sum of oxidation number of atoms present in an ion is equal to a charge on the ion. For example, in Cr2O7-2, 2 into oxidation number of Cr plus 7 into oxidation number of O is equal to -2. Oxidation number of N in HNO3. Oxidation number of H plus oxidation number of N plus 3 into oxidation number of O is equal to 0. +1 plus oxidation number of N plus 3 into -2 is equal to 0. +1 plus oxidation number of N plus into bracket -6 is equal to 0. Oxidation number of N -5 is equal to 0. Therefore, oxidation number of N is equal to +5. Oxidation and reduction according to the oxidation number concept. Oxidation is a reaction in which oxidation number of an atom increases. Reduction is a reaction in which oxidation number of an atom decreases. Redox reaction is a process in which oxidation number of one atom increases and that of other atom decreases. Oxidizing agent is a species of which the oxidation number decreases during a reaction. Reducing agent is a species of which the oxidation number increases during a reaction. Consider the following redox reaction. C plus 2H2SO4 gives CO2 plus 2SO2 plus 2H2O. Oxidation number of C is 0, elemental form. Oxidation number of C in CO2 is plus 4. Thus, the oxidation number of C in the reaction increases. It undergoes oxidation and therefore C is a reducing agent. Oxidation number of S in H2SO4 is plus 6, whereas oxidation number of S in SO2 is plus 4. Thus, the oxidation number of S decreases. It undergoes reduction and therefore S in H2SO4 is an oxidizing agent. Identify the oxidizing and reducing agent from the following reaction. 2KClO3 gives 2KCl plus 3O2. In the above reaction, the oxidation number of Cl decreases from plus 5 to minus 1. Therefore, Cl in KClO3 is an oxidizing agent. The oxidation number of oxygen increases from minus 2 to 0, and therefore oxygen in KClO3 is a reducing agent. Balancing of chemical equation. Redox reactions are balanced by using oxidation number method by the following steps. This method is based on the principle that number of electrons lost is equal to the number of electrons gained. Find the oxidation number of each atom from the given redox reaction. Identify the atoms undergoing change in the oxidation number. Write two half reactions for atoms undergoing oxidation and atoms undergoing reduction. Balance the atoms from both sides of the given equation other than H and O. Find the total increase in the oxidation number and total decrease in the oxidation number in the two half reactions. Make the total increase in the oxidation number and total decrease in the oxidation number equal by multiplying with suitable number to both or any one of the compound or ion containing atoms undergoing change in the oxidation number. Add the two equations and balance the remaining atom other than H and O if required. Balancing of oxygen atom. Extra oxygen atom from one side is balanced by adding H2O molecule on the other side. Each extra H atom is balanced by adding H plus ion on the other side. In basic medium, each H plus ion obtained is neutralized by adding OH minus ion on both sides. H plus OH minus gives H2O. Check that the reaction ensures the balancing. If possible, divide the entire equation with suitable number and bring the reaction in a reduced form. For reactions containing ions, net charge on both sides of the equation must be equal. Balance the following redox reaction by oxidation number method. P plus HNO3 gives H3PO4 plus H2O plus NO2. According to rule number 1, P plus HNO3 gives H3PO4 plus H2O plus NO2. According to rule 2, find the atom undergoing the change in the oxidation number. According to rule number 3, separate the oxidation and reduction reaction. Balance the atoms other than O and H. According to rule number 4, find the total increase and decrease in the oxidation number. Total increase in the oxidation number P0 to P plus 5 is equal to number of atoms into increase in the oxidation number, which is equal to 1 into 5, which is equal to 5. Total decrease in oxidation number N plus 5 to N plus 4 is equal to number of atoms into decrease in the oxidation number, which is equal to 1 into 1, which is equal to 1. According to rule 5, balancing of increase and decrease in the oxidation number. Total increase in the oxidation number into X, which is equal to total decrease in the oxidation number into Y. Therefore, 5 into X is equal to 1 into Y. Therefore, X is equal to 1, Y is equal to 5. Multiplying equation 1 by 1 and equation 2 by 5, P gives H3PO4, 5HNO3 gives 5NO2. According to rule 6, adding two equations and balancing remaining atoms other than H and O, P plus 5HNO3 gives H3PO4 plus 5NO2. According to rule number 7, balancing O atoms by adding H2O molecule. number of O atoms on left hand side is equal to 5 into 3, which is equal to 15. Number of O atoms on right hand side is equal to 4 plus into bracket 5 into 2, which is equal to 14. P plus 5HNO3 gives H3PO4 plus 5NO2 plus H2O. According to rule number 8, number of H atoms on the LHS is equal to 5 into 1, which is 5. Number of H atoms on RHS is equal to 3 plus 2, which is equal to 5. P plus 5HNO3 gives H3PO4 plus 5NO2 plus H2O. According to rule number 9, final balanced redox equation is P plus 5HNO3 gives H3PO4 plus 5NO2 plus H2O.